everyone. Welcome to the fourth session of Smart City Water webinar. I'm really glad that you guys can make it, and thank you so very much for doing that. Today, we are going to talk about the impact of climate change on land development. Without any hesitation, at first, I'm going to ask you guys, feel free to chat, talk to each other, or even ask any question on the chat option of this webinar. We're going to have a QA/QC at the end. If you guys have any question, we're going to share the question and the answer at the end. With no further delay, I'm going to bring up my presentation. And just for the record, this session is going to be recorded, is already being recorded, and is going to be published on our YouTube channel. Feel free to go and check it out after the session, probably 24 to 48 hours after the session is going to be published. Welcome to Smart City Water. I am Jason Mahmoudi. I am the technical specialist at Smart City Water. I used to work for a consulting firm for a few years as a water resource scientist and climate scientist. My background in climate science is for my master's when I graduated from University of Western Ontario in 2019. My thesis was mainly focusing on climate internal variabilities and external forcing and the impact of climate change and hydroclimatic variables on western of North America. The agenda of this meeting or this webinar is we're going to talk about the differences between the weather and the climate, and then why is climate changing and the impact of climate change on hydroclimatic variables. And we're going to talk about the hydroclimatic variables and where can we get the climate data and how to use the climate data in modeling. So at the very beginning, I want to talk about not the banana chocolate bread, but I want to talk about the differences between the weather and the climate. So as you know, these two terms somehow and sometimes are used interchangeably, which is a mistake. They're completely different. As we have a banana chocolate chip bread, the whole bread can be considered as a climate. So the climate is the state and the status of weather in a long period of time, let's say 15 to 30 years. However, one slice of that bread, which is the status of weather in one small segment of time, can be considered as weather. When we say that the climate of Canada is wet and cold, and if we see one winter that the temperature is not that low, the weather is a bit warmer than the previous temperature, than the previous winter, or we are not receiving that much of snow, does that mean that the climate is changing? Not necessarily. The fact is, sometimes when we're cutting a slice of that banana chocolate chip bread, we may end up not getting any banana in that slice, but that doesn't change the whole loaf. So that slice necessarily may not have a banana in it. So like the weather, this winter, we may not receive a very heavy storm or a very heavy snowstorm, but that doesn't change the entire climate of Canada. So we can't look at 1 year, one winter, and overgeneralize it that climate is changing. So we're getting warmer and warmer because maybe next year we are going to get a very cold winter with a lot of snow. Does that mean that the climate is changing to a colder climate? Not necessarily. So these are the differences between the weather and the climate. Weather is we're talking about shorter time, like maybe 1 day to 1 week, maybe 2 weeks, maybe a year, but that doesn't we can't overgeneralize it to the climate of an area. However, on the other hand, the time span of the climate is way longer than the weather. And why is climate changing? So the fact is, we do have some greenhouse gases. There are a lot of them, all sort of molecules. They do when we spread them, when we emit them, when they go to the atmosphere, they do have a span that when the radiation from the sun comes and hit any sort of surface, even when it passes the ozone layer, that radiation is losing its energy, and then when it's going to be emitted and um, fly away or escape away from our atmosphere of our beautiful planet, it actually will hit these molecules. And if these molecules, if the energy of this radiation is in the boundary of these molecules are going to be defending and not letting these radiation to escape away from the atmosphere. It's going to bounce it back to the atmosphere. So we're going to trap these radiation that we're receiving from the sun. So the more this radiation traps in the atmosphere, the higher the temperature is going to go, because we're going to have more energy in our atmosphere. The higher energy that we have, the more temperature that we have. The more temperature we have, the more moisture holding capacity we have in the atmosphere. The more moisture holding capacity we have, the more water is going to evaporate, the more water vapor is going to store in our atmosphere, the heavier the rainfall is going to be. So back to these molecules, carbon dioxide, methane, which one of the main important drivers of these methanes are the livestock that we have. So it's just in bracket, I'm just going to say that even the lifestyle of people who live in a country, or the even the food culture of people in one location, actually affect the climate, and it's going to contribute to the climate change. If meat is the most important and the main food culture of a region, that means that we need to grow, or we need to have more cows and more meat. The more cows we have, the more methane we're going to produce. The more methane we produce, the more defend line we are actually putting on the atmosphere of ours, and then the more these radiations are going to be trapped. So there are a lot of contributors to these climate change. Fossil fuels, again, food culture, wrong use of energy, and just deforestation. All of these things, we're whatever we do, that we create carbon dioxide, methane, nitrous oxide, ozone, even the water vapor. So all of them, if the more we have them, the more radiation is going to be trapped. The more radiation traps, the higher the temperature is going to be. So the impact of climate change on hydroclimatic variables. What do we mean by hydroclimatic variables? It works like a domino. When temperature rises, as I said, the moisture holding capacity rises. If that rises and temperature rises, we will have more evapotranspiration. We will have more moisture in in our atmosphere. The heavier the rainfall is going to be. If the temperature rises, we're going to have our sea ice is going to shrink. And then sea ice is a funny thing about the sea ice that I learned a few years ago from a very amazing senior engineer in CBCL, Vincent. Um, he taught me that because he was an expert in sea ice, and then he was saying that the sea ice works like, if one thing affect shrinking the sea ice, then the shrinking of the sea ice is going to affect itself. So as soon as we have less sea ice, that less sea ice is going to affect itself. So it's going to shrink faster. So that's why we have to preserve our sea ice. But with higher temperature, we're going to have less sea ice. Humidity, we're going to have more humidity. The reason is because the more temperature is, the more moisture holding capacity will be. And then the more temperature is, we're going to have more evaporation. And then so the humidity is going to be higher and higher. And also, there are so many studies that have been conducted over the drought as well as flooding. So this is also one of the consequences of climate change. We're going to have more droughts, and also extreme events, which was part of my thesis. The extreme events, um, it means any sort of drought or any sort of flash rain or any sort of flooding. The frequency and intensity of extreme events are projected to increase by climate change. For example, this is the global mean surface temperature. So using the data, we also have realized that the global mean surface temperature have been increasing after the Industrial Revolution from 1880s, and it has been increasing and it is projected to increase in the future as well. The other thing that we have is the impact of climate change on precipitation, and as we can see, not necessarily in all regions precipitation is going to increase or decrease, because the hydrologic cycle is an isolated cycle. So we're not going to have more water or less water. The available water is going to be scarce. So we're going to have less available water. The more evaporation is going to happen, the heavier rainfall is going to happen. The heavier rainfall, the more flooding we possibly will get. The more flooding we will get, the more endangered we are. So in some regions, even for temperature, in some places, temperature is projected to decrease. So we're going to have colder moments in some regions of the world, but the average, we're talking about the average or the mean global temperature that was increasing and is projected to increase. Same thing with the precipitation. The spatial distribution of precipitation is shown in this picture, that it is projected even to increase in some regions. If Western Canada is getting a lot of precipitation, it is projected that it's going to receive higher precipitation, especially in high elevation areas, especially in Columbia River or in Columbia Mountain or in Rocky Mountains in Western North America. So how do we have to project? How do we know about future? We have climate data. The climate data, or in other words, it's called global climate models. Also, there are other names for that, but it's known as GCMs, which stands for Global Climate Models, or General Circulation Models. So these models will tell us about the response of temperature and precipitation and wind and flood and etc., these variables, to shared socioeconomic pathways. What is shared socioeconomic pathways? SSPs are the different scenarios that have been used in the most recent GCMs. We do have updates of GCMs every 5 years. So right now we do have CIMIP 6, which is the most recent GCMs that we have, and they have different sort of scenarios. One scenario, if I want to put it in a plain simple word, it means that if we control the population of the world, if we're like, so it takes economic growth, technological development, population, and also concentration of greenhouse gases. It takes all of them into consideration and tell us what's going to happen to the precipitation until the end of 21st century. And some of them also tells us until the end of 22nd century, with a lot of uncertainty, absolutely. But it's giving us a kind of like a shadow of what is projected to happen. So that's the differences. For weather, we always predict, but for climate, we can always project the climate. So different scenarios of climate data, which is the GCMs, it takes economic growth, technological development, also population and concentration of greenhouses into consideration. So where can we get these climate data? So the climate data, we do have two different time sets and time steps for climate data. One is historical, whatever that had happened up to 22nd of June 2022. So that is called historical. And also we have projection, what is projected to happen to the climate from this moment till the end of 21st century. So the historical data, we have different sources for historical data. One of the most important one that have been used in consulting firm, I remember we used to use it, is the Environment and Climate Change Canada. From the website, they're station-based, mostly airport. You can just go and download different stations from different airports. There's so many very useful information, and kudos to whoever is maintaining, the team is maintaining those data. They're doing a great job. There are so many airports that you can just go and easily find out where or which station is the most beneficial for you to get the data from there. It has temperature, precipitation, wind, sometimes wind gust, visibility. Sometimes it depends on the station and how well maintained that station is. Another source for historical data is PCAC graded observation. So PCAC is an amazing source of any sort of graded data observed or GCMs that we will talk about it down the road. So after my presentation, I'm going to bring PCAC's website and go with each other to see how we can actually download data from PCAC's website. Another source of historical data is IDFCC tools or IDF climate change tools developed by University of Western Ontario and I think it was the Catastrophe Institute, Catastrophe Loss Institute, if I'm not mistaken. But the head of that team was Dr. Slobodan Simonovic, which I admire and one of my idols in climate science. So the IDFCC tools is going to, we will also bring IDFCC tools as well up there. So what it does is it actually gives you the entire map of Canada, and then you can go and choose either gauged station or ungauged station and choose your location or the closest point or station to your watershed that you want the data for, and then it's going to give you either the historical data or the projected with considering the climate change, the IDF for those specific places. So these were all the historical data. There are way more sources than this. You can just get it from conservation authorities or from the municipalities. It depends if they do have it, or there are so many other historical source of data as well. Some of the universities also have some historical or data collection centers that they actually store the data, but the mostly or the most commonly used ones are the Environment and Climate Change Canada, as well as the IDF Climate Change tool. So when we talk about the climate data for projection, there are, again, so many other tools. You can get it from the main source of GCMs and the CMIP6. There's so many of them. But when we talk about GCMs, they're gridded data. The raw data is normally 250 kilometer by 250 or maybe 100 by 100, but they're like very low resolution data spatially. They're like coarse data. The grids are so big, you may want to work with the watershed that is just going to be a dot or a point in that grid. So what PCAC does, and also PCAC's president is Dr. Francis Zuyers. Kudos to him. He is one of the biggest names in climate science in the world, an amazing scientist. So Dr. Francis Zuyers and his team in PCAC, they downscale spatially, they downscale all of these raw models for the entire Canada, and also they bias corrected it using the actual values that we have. By bias correction, what I mean is each sort of data, we have a distribution for that. And what it does is the distribution of the GCMs might be different from the distribution of the observation data. What they do by bias correction is they try to modify the distribution of GCMs and they try to match it to the observation distribution to follow the same pathway. So PCAC has already downscaled and bias corrected all of these GCMs. Again, after this presentation and the slides, I'm going to open their website and we're going to go through it. And another source for the projection climate data is IDFCC, which we talked about it already in the historical data. IDFCC is brilliant. So if you have your watershed model And if conservation authority or municipality ask you, hey, I want also to see the impact of climate change on this development of yours. So a common mistake is also saying that, hey, yeah, what we ask is inflate your precipitation by 20%. Where does that 20% coming from? Where is it coming from? That 20% has absolutely zero scientific logic behind it. It is a common practice, a common approach. However, it doesn't tell us anything. Well, a very easy approach to do is getting the IDFCC data. So in IDFCC tool, which is a website, all you need is just to create an account, which is a free account. You can go and choose your station or choose your location. It's going to give you the IDF curve considering the climate change on that IDFs, and it can choose the span of the year. For instance, I want the data from 2049 to, let's say, 2070. So, or 2080, the 30-year span. So, or 2079 or whatsoever. You can choose the time span and then choose the different scenarios. It does have different scenarios. You can choose the worst case scenario that can happen based on the live climate data that we have. So you can choose it and it's going to give you the IDF curve for those specific regions. So IDFCC is another tool to get the data from the projections. So talking about the historical climate data, Environment and Climate Change Canada, I assume that a lot of you guys have already used it or are using it or want to use it down the road. One of the difficult part of it is when you go and find a station, you will see this screen. You can download the data, but you need to download this data. When you click on download up here, it is going to download only one page of the data, which is for this date, which I assume this one, which is for this month, June 2022. It's going to give you only the data for this month. But if you want 20 or 30 years of data, you need to click on get more data. It's going to take you to a page. You need to download Sigwin, and then you need to do a bit of coding. It's going to give you a bit of a headache. If you had done it before, you know how to do it, so you get used to it. But technically, it's going to give you a bit of a headache. One of my colleagues, who I still do a lot of publication with him, his name is Harry Singh. He actually does a fantastic job and came up with a kind of like a tool that you can use it for free. And by only using the station ID that you can find it up here, as I put it around the circle. So if you choose a station and if you want to download the data, if you go through the URL, in URL, you can find the station ID. The station ID, for instance, for this specific one for Barrie Landfill, Ontario, is 50048. And just by copying this to the tool that Harry Singh developed, you can just put the station ID here, click on process the data, and it automatically will collect all the data available in that station. And then you can just download it without uh, downloading it Segwin or without coding, without anything. This is a fantastic tool. I've used it before, and I highly recommend whoever wants to use the Environment and Climate Change Canada just to simply get the station ID from the URL, which you need it anyway. If you want to get more data, it will ask you about the station ID anyway. So, but you need to go and download Segwin, and you have to take some of the steps. It's gonna give you a bit of a headache if you don't know how to use it. But if you know this station ID, you can just use what Harry Singh, kudos to him, what he developed, and then just put the station ID in the station ID call to action, process the data. You can easily download the data with no issue. It's going to take around 5 to 10 seconds for you to collect all the data and give you the data. I'm going to provide the link to the tool to Harry. We also can open it as well. And this is a screenshot of IDFCC tool. So that's what I was talking about. The gauged location and ungauged location. You can just zoom in, find your location, get the data that you want, either for historical data for any location you want. If you don't have the data in a watershed that you're modeling, if you want the data, if you want the IDF curve, you can use IDFCC. And also, if you are required to find out the impact of climate change on your modeling, you easily can use the same tool, which is IDF climate change or IDFCC tool 6.0, as you see it up here. And you can get the IDFCC for that specific location. So, but um, one of the controversial topic is how to use climate data in modeling. So the common practice is we model our watershed. By modeling, I mean the subcatchment, the catchment, the conduits, everything. We model it, the slope, the roughness coefficient for impervious, pervious. We do everything. We model our watershed, and at the end, we add the rainfall data or the temperature data or the snow or whatsoever, and then at the end we run the model for the existing condition. And then we want to calibrate our model. Sometimes we do it, sometimes we don't, but we calibrate our model using an observed runoff data. So if I have an actual data, I want to make sure that my model is also working properly and get it closest to the actual data, because all models are wrong, but some are useful. No models are accurate. All of them has an uncertainty level. Maybe it's 1%, maybe it's 20%, maybe it's 70%. That doesn't make them the that that's why we have model. Model is something the closest to the real life, but it's not the real life. So we need to calibrate to get it closest to the observation. And then if we want to find out the impact of climate change on our watershed, what do? We just use the projected precipitation for 2040 to 2050 from IDFCC, as well as the temperature. We just put them in our model and say, oh, this is the impact of climate change. So if the climate changes in 20 or 30 years from now, this is what's going to happen. This is the amount of runoff that we're going to get. But the question scientifically, this is the common practice in industry. But the real question in industry is it accurate? That one of the best paper I've ever read in my life was a paper in 2018 by Ashish Sharma and his amazing team. The title of that paper was, "If precipitation extremes are increasing, why aren't floods?" What he did was he did a bit of investigation about observed value globally, and he said that globally the precipitation extremes have increased, but globally the average global flooding haven't increased yet. So does that mean that the climate is not changing? No, that's absolutely another thing. But he is saying that if we only think that our watershed is going to remain the same, the slope, the land cover, land use, vegetation, soil moisture, land development. If we think that our watershed is going to remain the same, and the only thing that is changing in 20 years from now is precipitation and temperature, that's not correct. Because maybe 20 years from now, of course, the precipitation is going to change, the temperature is going to change, so does the land use, so does the slope and the vegetation and also the land development. So what do we need to do? Right now in academia, in universities, what they're trying to do is they're trying to find out the impact of climate change considering the land use change. They're saying that because of the population, because of the socioeconomic aspect of our society, we are going to have different land use. If we had an agricultural area in this watershed now, and we think that it's going to be the same in 2040s, probably it's not going to be the case. Probably that agricultural area or that pasture land is going to change to a residential area, or that residential area is going to even, there is a possibility that that residential area is going to go to an industrial or a commercial location. So if we only put the precipitation or temperature as the only variable in our watershed to find out the impact of climate change on runoff in our watershed, that is scientifically not accurate. That was my presentation. I'm going to open the websites that we were talking about. So I'm going to open them and then we can go from there. The first thing that I wanted to bring up, let me just share my screen here. So this is what Harry Singh came up with. I'm going to also send you in the chat the link of this. So this is the link. You all have access to that. If you just click on it, it's going to directly take you to this website. So if you put the station ID of any sort of, let's say, station that you want from Environment and Climate Change Canada, it's going to give you easily the data for that one. As an example, for example, I want to get the data for that Barrie Landfill, Ontario. The station ID was 50048. If I easily put 50048, process the data, I will receive this saying that processing this data. The data is ready. Click on download to download the data. And I click on download and I already got the data. And then I can just start using the data. This is that easy. However, if you want to go for Environment Canada, for instance, for the same station, let's say, I just randomly bring one station. This station, if I want to get more data, it's going to take me to this Google Drive that I have to download the SIGWIN. I have to learn about the command lines that I need to put on SIGWIN to get the hourly data or the daily data or monthly data. And also I need the station ID here anyway. So this is the station ID that I was talking about. But if I want to just go for an easier approach, I easily can use what Harry Singh came up, and it's free to use, so feel free to use it. So if I want to get the station ID for this specific station, which is, the name is Abbey TB Canyon, Ontario, what I need to do is I need to go, this is not the station ID, by the way, so common mistakes. These are not, the only place you can find the station ID is going through the URL, and then in URL, it says station ID. So this is the station ID, 4141. If I want to get the entire data for this specific location, all I should do is going back here, 4141, process data. It's processing 4141. And it's going to give me the data for 4141. And by clicking on download, you easily can just get the data. Climate data had been downloaded. So that is one of the website that we talked about. The other one was PCAC. So if I just Google PCAC, the first website is the Pacific Climate Impact Consortium, which is the PCAC website. Again, it is freely available. Feel free to use it. If you want any sort of gridded data, the best source in Canada. I'm obsessed with this website. So data portal, if you click on it, it's going to give you either the daily gridded data, which for instance, we're going to see it, access and download gridded meteorological data set. This is the data set that is available for Canada. There are 3 different data sets available. NRCan Met, PBC Met, and PNWNA, which is the Pacific Northwestern North America meteorological data for 2015. And then you can just get the data, but however, just make sure that the data range for these data sets are a bit limited from 1945 to 2012. For instance, I want the precipitation for, let's say, Ontario. I can just easily zoom in, and I want the data for the gridded data for this specific location. I can just easily go and choose where I want to get the data from. This is my location. I selected it. I want to download the full time series, yes. Or if you want from one year to another, you can just get it from here, and then it can export on ASCII or on netcdf files, which netcdf you can open it on MATLAB or on OR or any other programming softwares. Netcdf files are the gridded files, which are the 3D files. You have X and Y, the latitude and the longitude, and also different sheets are going to be different days. So you're going to get 1D and 2D, which is the latitude and the longitude and the values in it. And then the third dimension is the days or the years. If it is daily, different days. If it is monthly, different month. If it is annually, different years. So that's the structure of netcdf files. Also, this is only the daily gridded data that PCAC has. If you want the statistically downscaled climate scenarios, you can just easily click on this and get the. It does have both CMIP 5 and CMIP 6. CMIP 6 is the most recent one. I want to get the CMIP 6, for instance, access and downloading it. It's going to give you 3 scenarios: SSP 1, 2.6, SSP 2, 4.5, and SSP 5, 8.5, which is the worst case scenario. And it has different GCMs. If you want 5 GCMs, you can download 5 GCMs. If you want 10, it's completely up to you. I want, for instance, this GCM. I will click on it. Do I want precipitation, maximum temperature, or minimum temperature? Let's say maximum temperature. I click on it, zoom in. Again, same process. I want to get the data for, let's say, Halifax. So I just choose Halifax, and then I come down here. I want the full time series. I just click on download. It's going to start downloading it. So that's how, and it's downloading the data for this selected area that I want. If you want more, just increase your selection area. So that is one of the approaches for the CMIP 6 data, the GCMs. So I'm just gonna cancel this. So this is the PCAC website. The other website that we talked about is the IDF-CC. The IDF-CC, all it needs for you, if you want the gauge location, you can just click on it. It's going to ask you either to register or to log in. So I believe that I still have my, yeah, there we go. I still had mine. So I have my own account. You can create your account for free. It's free and feel free to use it. The IDF for gauge location, if I click on it, it's going to take me to this map. Let's say I want some data for Newmarket. So it's going to give me these locations. These are the available locations that I can get the data. I want close to Oak Ridge. So I click on it, this gauge location. This is the info of the location of the station, number of years 17. So it's going to give you an idea that the IDF that is being created is based on 17 years of data. So IDF historical data, it's going to give you the IDF curve for historical data, either by total PPT or intensity rate. If you want the intensity rate, you can just select the intensity rate. If you want it plotted, you can just get it plotted. If you want to use it in your report, it's an amazing thing. You can just get the screenshot and use it in your report. And this is based on GEV distribution. If you want it by Gumbel distribution, just select on Gumbel distribution. If you want it plot or different things, it's going to give you that. If you want to see the impact of climate change on this IDF under climate change. When you select IDF under climate change, it's going to ask you for climate model selection. So you can select CMIP 6 GCMs or CMIP 5 GCMs, or you can select the PCAC bias corrected CMIP 6, because if the data is not bias corrected, some of the data are biased. For instance, let's say CAN ESM5 is one of the GCMs, one of the models that projects the temperature and the precipitation down up to the end of 21st century is CAN ESM5. So imagine if you're doing a project in, let's say, Caribbean, CAN ESM5, because it's a Canadian organization, the main focus is on Canada. It is projecting everywhere globally, but the data may not be accurate or may not, it might be biased in some area, and you need to bias correct the data. PCAC over Canada has already unbiased or bias corrected all the GCMs for you. So I want the PCAC bias corrected Sim 6 because it's the most recent ones. If you want specific ones, you can select them. I want all models because if you use many models, if you use more than 5, 6, 7, the more models you use, the less uncertainty it has, or the closest to the reality it will get. What I said is very controversial if we want to talk about it scientifically, but most common practice is using all models or more models than only one. I want to find out this, let's say 2040 to 2069. I want 30 years of data. 2040 to 2069, all models, this one. And if I just go and select calculate IDF for future, it's going to give me the SSP 1.26, SSP 2.45, and 5.85. If I want the worst case scenario, I'll select on that one, 5.85, and it's going to give me the intensity for 5 minute, 10 minute, 15, and etc. This is the IDF values for that specific station, considering the climate change on it, in a climate change. So if I wanted to plot it, you can get it plotted by, again, this is GEV. So if you want a box plot uncertainty, it's going to give it a box plot. Fantastic tool. So that was the station-based one, or the gauged location. If I want the ungauged locations, if I'm working on somewhere that I don't have any info about it, for instance, I can just go and select, let's say, I just clicked on that specific location. It interpolate and it will give you based on the gridded data that they have on that specific location. So for instance, if you're working on a project in the middle of nowhere and you don't have any station close to that watershed, let's say here, I believe that there are some stations close there, but let's say there is no station. I just click on that. It's going to give me the historical IDF. It's going to give me the plots, interpolation equation, how they got this data, only by GEV, the table, the intensity rates, and etc. And if I want to find out the impact of climate change on that, I just click on that one, select my the period of time that I'm looking for, and the same approach. It's going to give me the result for that one. And also, if you select less than 30 years, it's going to give you this notification that you need to choose at least 30 years of data if you want to see the impact of climate change. So I will say you can get more than that. So I want the bias corrected PCAC. So it's going to give me the data. So that was all the website that we talked about in our presentation. Feel free to ask any question if you guys have. You can just raise hands and I can give you the mic, or feel free to just ask the question on the chat, and then we can go from there. Does anyone have any question? I will take that as a no. All right. So, if you guys had any question even down the road, feel free to email me. You all have my email. Oh, absolutely. Someone is typing. So if you guys have any question down the road, even after this meeting, feel free to email me. Even if you want the material that we talked about, the PDF or etc., just feel free to let me know. I believe that Rolf and Asif, they're typing, so we'll wait for a bit. Um, absolutely, yeah, I can. Because the reason that I don't send out the presentation to everyone after the meeting is because I don't want to bug you guys with a lot of emails. But whoever wants the material, the websites and etc., just feel free to email me, and I'm more than happy to let you guys know. I'm going to just right here give you, this is the IDFCC, this is the website, and as well as the climate data. So the environment and climate change, I will give you the website for that one as well. And on top of that, the PCAC. So this is the PCAC, and I believe that I already um, gave you guys the tool that Harry came up with for Environment and Climate Change Canada. Rolf asked, sorry, I joined the meeting late. How do you feel about temperature scaling versus the UW approach for adjusting IDF curves for climate change? Do you mind if you elaborate about temperature scaling? Because what UWO is doing is technically getting the climate change data. So, for instance, the projection done either by PCAC or the raw data of CMIP6 GCMs, they're choosing it, they're using the graded data for that specific location and fitting a distribution on it, either GEV or Gumbel. You can do it yourself if you know R. You can easily just do it and getting the IDF curves for yourself, because what why does RDF curve changes with climate change? Is because right now, how do we get the IDF curves is we are saying that the 50-year precipitation right now is, let's say, 10 unit, 10 millimeter per second, for instance. 10 millimeter per second is the 50-year precipitation right now. How do we get this? We use a historical data and we say, okay, this is the 100-year of value, and I fit a distribution, and the area under that PDF, which is, let's say, 50 years, is going to give us the data, the actual value, which is 10 millimeter per second for right now. But down the road, because temperature is projected to change, we're going to have probably heavier precipitation or heavier temperature or more intense and more frequent high temperature and precipitation. The historical data in 2040 is going to be different. So it's going to be, the precipitation is going to be higher. So the 50-year precipitation also is going to be higher. So that's where the IDFCC is going to be used. 1.07, the power of changing temperature. That's new to me. I haven't, yeah, I am not familiar with this, Rolf, and I would really appreciate if we can just give me some info about that one, even after the meeting. I would really appreciate if you can just email me and sending either a document on a paper or something that because I believe this looks like an industrial common practice because it's an interesting one. But yeah, I would highly appreciate if you can just send me a document or something, or if you want to share it here, that would be fantastic. Asif asks, what is your email address? Oh, absolutely. So I sent the link of the meeting using my email address. Feel free to just reply to that one. But I'm going to just write my email address here as well, just in case if you guys don't have it. Jason Mahmoudi at smartcitywater.ca. Do you have a recording of today's presentation that you can provide? Absolutely. All the webinar session, 2 or 3 days after the webinars, we publish them on our YouTube channel. If you want to go back to the first session or the second session or the third one, we have them all. We have all of them on file on our YouTube channel. I will also provide a link to our YouTube channel as well. Feel free to just go there and yeah, you can get any webinar session from our YouTube channel. All right. If anyone else has any question, feel free to ask. Otherwise, I really appreciate your time. Thank you so very much. That was the fourth session of Lunch and Learn. There is no lunch. A lunch is not yours. Uh, no lunch, but learn of Smart City Waters webinar. The fourth session, we talked about the impact of climate change on land development and how to get the data, the climate data, and how, if you want, you can get all of those data and import it to Visual iThymo or VioSwim. And we will have more sessions. I'm going to update you guys about the next sessions. Make sure you follow us on our Twitter as well as the LinkedIn to get updated with our content that we release every week. We have cool features coming out. The next release of Visual iThymo and VioSwim is also coming. We are very excited about that one. We have a lot of great news for you guys. Thank you so very much. And we will be in touch with each other. Stay safe, be happy, and make happy. Have a good day. Cheers.